Let's talk today about solving equations, and I'd like to talk about the addition property. And first what I'd like to do is I'd like to demonstrate via this balance scale, like you might have seen in a science classroom way back. What I've attempted to draw here is a scale that is balanced because on the left side and on the right side are two blocks that are equal in weight. And what I'd like to share with you, and it's what we do with equations in order to solve for the letter x, I'd like to share with you that I could add, I'm going to put a block right here. I could add a red block to the left side of the scale, and I could add a red block to the right side of the scale that are equal in weight, and nothing has happened to the scale. It has remained absolutely level. And so what we're going to do is we're going to think of equations as a balance scale, and the equal sign is going to be what's on the left is going to be equal to what's on the right. And at any time, if we would like to add something to both sides of that equation, or if we would like to take away something from both sides of that equation, we may. So the first few problems that I'm going to do with you today are very simple problems, and it uses what's called the addition principle, but I want you to know that we can also take away. So let's get rid of this diagram, and let's solve this problem. I want to solve for the variable t. So I'm trying to isolate that variable. And I can use this addition principle and apply it to both sides of the equation. Remember the balance, the tipping point is right here. This is equal to that. And so I can add the same thing to both sides, or if I'd like, I can take away the same thing from both sides. I'm going to choose to take away 17 from both sides of this equation because I have 17 here. If I take away 17 from it, I have 0. So that leaves this variable t all alone now on the left-hand side of the equation. Again, this plus 17 and minus 17 add to be 0. Don't write that down. It becomes confusing. And then 42 minus 17 is equal to 25. Once I have my solution, in this case I do, I'm all done. I found out that t is equal to 25. One of the things you should get in the habit of doing, because you can guarantee for yourself that you've gotten every problem correct on your test, is check. I won't have the opportunity to do all of them because it just takes some time and the videos load fairly slowly possibly for you. The original equation is t plus 17 equals 42. That's the original problem. I found my answer to be 25. So for the letter t, I'm going to substitute in my answer, and I'm going to ask myself, does 25 plus 17, what does it give me? And it gives me a value of 42, and I could say, well, yeah, the left side does equal the right side, so I must have found the correct solution. This is a real important part of the solving equation process. Let's look at one where we might have to add something to both sides. So I've got x minus 11 equals 42, and I'm trying to isolate the variable x. I'm trying to get it alone. So right now there's a minus 11 with it. The way to get rid of a minus 11 is to add 11, because a negative 11 and a positive 11 add to be 0. But if I add 11 to one side, I've got to do it to the other side of the balance scale. And so finally I'm going to find out that x is equal to, I'll go ahead and add those two positive numbers. They add together to be 53. I should do a check. I'm not going to take the time right now because I want to put a problem in here that's got fractions. I could have talked through that check. Maybe one other thing I want to mention to you while I'm doing a problem that involves decimals. And this time I've chosen a problem also where the variable x is on the right-hand side. It does not matter which side it's on. And then next, I'd like you to know that the author of our textbook and the author of many textbooks, when they see this minus 7.4, they say, I should add 7.4 to both sides. I'd just like you to notice that I add my 7.4 right below that minus 7.4, and I make sure to put that over here underneath that like term. So I add 7.4 here. Our author does it like this. They do it in a horizontal fashion. They add 7.4 here, and they might put it right next to the 8.6 in the next step. I'm going to tend to stay away from that and do a vertical approach. You may certainly take the approach that the author does. A negative 7.4 and a positive 7.4 adds to be 0. And then 8.6 and 7.4 adds to be 16.0 or 16. There are 3 significant digits there, but in our class we could just go ahead and call that 16. Again, my check would be to take the original equation, which was 8.6 equals x minus 7.4, and just substitute right there in for x a value of 16. And just check and see if 16 minus 7.4 is indeed 8.6. It is, and we can say that we're correct with that solution. Finally, one last problem until we take a look at the multiplication principle. A couple of things here that I'd like to share with you. First of all, I'm going to take away 4 2/3 from both sides of this equation. But when I do that, I want you to know that whenever I have a mixed fraction, I turn that into an improper fraction to work with it. It is much easier to work with a fraction in improper form. Improper form means its numerator is larger than its denominator. I have 4 wholes here. It's in parts of thirds. I take this 4 times the 3 and I get 12, and then I add 2 to it. So that gives me 14 thirds. That's the improper fraction for 4 2/3. Right here, 4 times 5 is 20, plus the 1 is 21 over 4. It is much easier to work with those fractions like that. And now what I'm going to do is I'm going to subtract 14 thirds from both sides of this equation because I want to isolate x and get x alone. These cannot be subtracted because they do not have a common denominator. The common denominator is a 12. So I'm going to multiply this fraction by 3 over 3, and I'm going to multiply this fraction by 4 over 4, so they both have a denominator of 12. Upstairs here I'll have 63 twelfths. Right here, let's see, 56, that's a negative 56 twelfths. And I want to go ahead and take the positive 63 twelfths and subtract the 56 twelfths, and I'm going to get 7 twelfths. Again, those add to be 0, and I have isolated the variable x. X is equal to 7 twelfths. Hopefully I can do a real quick check. So there's my answer, 7 twelfths. I'm going to put that in here into the original equation. Actually, I might go ahead and put it right here. I'm going to take away this portion and take the 7 twelfths and check it. So I wonder if 7 twelfths plus 14 thirds will give me 21 fourths. That's the check that I'll do. I have to get this fraction to have a common denominator of 12. So I'm going to multiply it by 4 over 4. That numerator is going to become 56 over 12. And here I have 7 over 12. And I add those together and I get 63 twelfths. And I wonder if that reduces into 21 over 4. That's my hope. I'm fairly certain that 3 will go into 63 21 times. 3 will go into 12 4 times. And the left side is indeed equal to the 21 fourths, which is on the right-hand side. This is our first property for solving equations. It's called the addition property. We can either add or subtract something from both sides of an equation to isolate the variable x.